Okay, this is the last video for today, and we will go through my solutions for the exercise. The first part is we want to try Minkowski with the degree as 3. So I created the k-nearest neighbor classifier. I specified the n of the neighbors to be 1, and you can try different things. And degree p-value is 3, and then the matrix is Minkowski. And I need to initialize the machine learning model, and then I train that with the X train and Y train. After that, I make the prediction and I create a confusion matrix, and this is the result. If you have something different to what I had, probably the reason is when you did the train and test split, there are some randomization in this process, and it is possible that you get something not exactly the same as what I got, but you should have something pretty good anyhow. And the next part, we want to try to use Minkowski with the p-value as 1. So this is 1 degree polynomial Minkowski, and that is, remember we discussed earlier, that is Manhattan distance, and we specify the n neighbor to be 7. So this is the first model. We use the 7 nearest neighbor and then the Minkowski distance with the degree as 1. And as we said, it should be the same as the Manhattan distance. So I created another one. That is, the n neighbors is 7, and then the matrix is Manhattan. So in this case, I'm using Manhattan, and in this case, I don't need to specify the p-value. So in this one, you can see I only use 2 parameters, the n neighbors and the matrix. Well, you may get some different results than I had, but you will find this result and this result, they should be the same because they are actually the same machine learning model behind the scene. Okay, the last part is the additional one. Well, think about that. Well, just now we tried 1 nearest neighbor, 5 nearest neighbors, and 7 nearest neighbors. So what is the best k-value? This is the part we don't know yet. To figure that out, one thing we can do is we can try different k-values. So I can just change this value and then run this box again. Say I change it to 3. And I run this again. And I find the result was a little bit worse. So it may suggest that 3 nearest neighbor is not as good as 7 nearest neighbor. But I do have to try a lot to find the right k-value, right? So how can we find that in a better way, in a more efficient way? That will be the topic later. So anyhow, this is the lecture for today, and I will see you guys later. And stay safe, stay healthy, everyone. Bye.